Welcome back to the OpenAI Associate Developer course. In this lesson, we'll dive into the output generated by the Transcription API call, specifically focusing on the timestamp granularity's configuration properties influence. We'll understand every detail of the timestamp granularity output. With the timestamp granularity's property, you can have your output at the segment level or word level. If you set this property to both segment and word, the output will include segment timestamp information first, followed by the word timestamped output. We will first discuss the segment-level timestamp granularity's output, followed by the explanation for the word timestamp granularity's output. Before looking at the specifics of segment or word timestamp granularities, let's examine the output properties they share in common. These common properties you'll see in the output, regardless of the timestamp granularity setting, are task. This indicates the task the API executed. Since this output is from the STT API, it will always have the value transcribe. Language. This string identifies the language of the input audio. Note that it is not in ISO 639-1 format. Duration. This number represents the length of time the input audio plays in seconds and fractions of a second. For example, 4.5 means 4 seconds and 500 milliseconds. Text. This is the transcribed text of the entire audio file. These common properties will always appear in the output and will be followed by an array of either segment or word timestamp objects. And again, if you set the timestamp granularity to both segment and word, you'll see an array of segment timestamp objects followed by an array of word timestamp objects. Now, let's take a detailed look at the segment-level timestamp granularity output properties. First, ID. This is a unique identifier for the segment and is typically an incrementing value corresponding to the segment's index in the segment array. Next, you have the seek property. This property indicates the location in the audio file where the segment starts. For example, if the seek value of the first segment is 0, it means the segment starts at the beginning of the audio file. Additionally, if the first segment is 5 seconds long, then logically the next segment should have a seek value of 5. However, you may notice that multiple segment records can have the same seek value, even if each segment duration is more than 0 seconds. This occurs due to the technical details of threading and parallel processing, and in the algorithms the AI uses to process the audio file. As multiple segments can be processed simultaneously, the seek value can be the same for multiple segments. While the seek value can be useful, be careful how you interpret its value in your applications. Next are the start and end properties. These properties indicate the start and end times of the segment, indicating the timestamp when each segment occurs in the audio file. Also, you'll use these properties to determine the duration of the segment. The start and end properties are followed by the text and token properties. The text is simply the transcribed text of the segment, and the token array contains the token identifiers of the text. If you recall from earlier lessons, you can use the OpenAI tokenizer tool to discover the token values of a segment of text. The URL again is https://platform.openai.com/tokenizer. Next is the temperature property. The temperature property in the segment's timestamp output represents the randomness the model used in generating the segment's transcription. This value will be close to that of the temperature property's value you set in your transcription's configuration object. Before we look at the probability parameters, we'll first look at the compression ratio property. Essentially, this property is a measure of the efficiency of the transcription relative to the original audio input. Here, a value of less than 1 means the transcription is more concise, using fewer characters than what's in the audio. A value greater than 1 means the transcription uses more characters than the original audio length. Also, a value of exactly 1 does not necessarily mean there are exactly the same number of characters or tokens in both the transcription and audio. What this would mean is that the transcription is as concise as the audio input relative to the complexity of the language used. However, a value of exactly 1 is unlikely in practice. To understand why this property may not be 1, consider that certain elements might get compressed. For instance, filler words, pauses, and non-verbal sounds such as or when someone constantly uses the word like as a filler word. These are all examples of what might not be transcribed by the AI, and thus reducing the number of characters in the transcribed text. Additionally, the model may combine multiple words into a single token, further reducing the length of the transcribed text. For numbers greater than 1, the model could have added more characters or context to make the transcription cleaner and more readable. Okay, now let's look at the probability parameters. There are 2 probability parameters in the segment output. 1, the average log prob parameter, and 2, the no speech prob parameter. The average log probability is a measure of the model's confidence in the segment's transcription accuracy. If you recall from our earlier discussions of logarithmic probabilities are used because they can handle very small numbers more effectively. In this context, AVG log prob represents the average log probability of the tokens in the segment. Remember, the closer the logarithmic probabilities is to 0, the higher the confidence in the transcription's accuracy for that segment. Therefore, a less negative AVG log prob value indicates higher confidence, while a more negative value indicates lower confidence. Next, we look at the no speech prob parameter. The no speech prob stands for no speech probability, and it measures the probability that a segment contains no speech. The value ranges from 0 to 1. Note that this is not a logarithmic probability, but a standard probability value. Therefore, a value close to 0 indicates high confidence that there is speech in the segment, while a value close to 1 indicates high confidence that the segment contains no speech. And here we can see an example of an entire segment-level timestamp granularity output object, with some example properties filled in. Okay, that wraps up our discussion on the segment-level timestamp granularity output properties. We'll now move on and look at the word-level timestamp granularity output properties. Looking at the word output, first notice the properties preceding the word array are the same as those which precede the segment output. However, the output properties of the specific word element of OpenAI's transcription timestamp granularities, you'll see each word property element contains a somewhat simplified JSON object. Here you have the start and end properties. These are identical to the start and end properties of the segment elements and identify the timestamp in the audio, showing when the word started and the time the word completed. And for the word object, you have the word property, which is exactly that, the word that has been transcribed from the audio. For each word in the word array, this is all there is to the complexity of each element in the words array. Looking back on this lesson, we have covered the segment and word output as determined by the value you set in the timestamp granularities configuration property. We have looked at all the properties which are returned based on if you set the timestamp granularities property to segment or word, or both. The only point to reiterate is to remember that when both segment and word are both set, the common properties, task, language, duration, and text are always the first elements of the transcription's output, and that both the segment array and word array will be contained in the output. In summary, we've covered all the output properties returned by the OpenAI Transcription API. We delved into both the segment and word outputs as determined by the timestamp granularities configuration property. We also explored the common properties, such as task, language, duration, and text that are returned regardless of the granularity setting. Understanding these properties is crucial for effectively using the Transcription API and extracting meaningful insights from the transcribed audio. By mastering these details, you can enhance your application's ability to process and interpret spoken content accurately. In our next lesson, we will explore the OpenAI Translation API. This powerful tool will enable you to translate text between different languages and open up new possibilities for multilingual applications and services. Stay tuned for our upcoming lessons as we dive into the Translation API and continue to expand our understanding of OpenAI's capabilities. Let's keep pushing the boundaries of what's possible with AI-powered applications.